Hello everyone, I am presenting on the topic about detectors in gas chromatography. First, we study about what is gas chromatography. In a gas chromatography, the sample is vaporized and carried by a inert gas through a column coated with a stationary phase. Different components travels at different speeds depending on their volatility and interaction with the column material, causing the separation. And next, we study about types of detectors in gas chromatography. First one, thermal conductivity detector. It is a universal non-destructive gas chromatography detector that measures the concentration of sample components by detecting the changes in thermal conductivity of carrier gases using a heated filament, typically platinum or tungsten. It works on the principle of the different gases conducted heat at different rates. Working of thermal conductivity detector, the TCD compares the two gas streams, a reference stream containing only carrier gas, a sample stream containing carrier gas, and an inlet. Both the streams pass over the heated filaments. Pure carrier gas cools the filaments uniformly. When the inlet enters the sample stream, the thermal conductivity of gas changes. That changes the cooling effects of the filament, causing the temperature and electrical resistance to increase. The change is converted into electrical signal and recorded as a peak in the chromatogram. Advantages and disadvantages of TCD. Advantages: it detects the both organic and inorganic components. Samples can be recovered after detection. Provides stable baseline during analysis. Useful for gases like oxygen, nitrogen, carbon dioxide. Disadvantages: low sensitivity. Variation in carrier gas flow affects the results. Detector performance changes with temperature fluctuation. Impurities can be affect the accuracy. Flame ionization detector. It is a highly sensitive scientific instrument used to detect and measure the hydrocarbons and organic compounds in a gas stream. Working of flame ionization detector. The sample from the gas chromatography column enters the hydrogen and air flame. The high temperature of the flame ionization the organic compounds and produces ions and electrons. The potential difference is applied between the burner jet and collector electrode. The current generated is proportional to the amount of carbon present in the sample. The amplified signal is recorded as peak of the chromatogram. Advantages and disadvantages of flame ionization detector: very high sensitivity, detects very small amounts of organic compounds, gives quick and accurate results, produce stable and reliable signals, provides clear chromatography peaks, excellent for organic and petroleum products. Disadvantages: destructive detector, sample is burned during the detection, cannot be recovered, poor response for gases like CO2, H2O, SO2 and NH3 etc. Needs hydrogen and air supply due to gas consumption and maintenance, higher operating cost. And next, electron capture detector. It is a highly sensitive gas chromatography tool used to detect the trace amounts of electronegative compounds such as halogens and nitro compounds. It operates by using the radioactive source. Working of electron capture detector. The detector contains a radioactive source, usually nickel 63, which emits electrons. These electrons collide with the carrier gas molecules and produce many low energy electrons. When analyte molecules enter the detector, they capture some of the electrons and from negative ions. The decrease in the current is proportional to the concentration of the analyte. The signal is amplified and record has a peak on the chromatogram. Advantages and disadvantages of electron capture detector. It is a very high sensitive. It can detect extremely small amounts of compounds, highly sensitive to halogens and nitro compounds, suitable for trace of analysis, widely used in pollutant and pesticides detection. Disadvantages: selective detector does not detect all components, requires careful handling and safety precautions. Detector handling and disposal increases cost. Not suitable for hydrocarbons and many organic components. Impurities can affect the detector performance. And next, photonization detector. It is a highly sensitive portable gas detector used to measure the volatile organic compounds and hazardous gases, typically in concentration from 1 ppb to 1000 ppm, using ultraviolet lamp to ionize the gas. Working of photonization detector: the sample gas enters the detector chamber. The UV lamp emits ultraviolet light with high energy. When the UV light strikes molecules with low ionization energy, the molecules become ionized and form the ions and electrons. The voltage applied inside the detector attracts the ions towards the collecting electrode. The current generated is proportional to the concentration of the analyte present in the sample. After detection, the ions recombine to form the original molecules, making the process non-destructive. Advantages: high sensitivity detects very low concentration of gas and vapors, gives quick detection and analysis. Sample is not destroyed during detection. Excellent for volatile organic compounds. Easy to use and maintain. Disadvantages: only compounds with low ionization energy are detected. Lamp becomes weak and contaminated over the time. More expensive than other detectors. Performance may reduce in dirt environment. Thank you.